Alright, finally a little bit of an E7 porting update. So I'll just show this real quick. So I've been working on finalizing the exhaust ports, or rather the exits, and you can see what I did. I kind of made them D-shaped. So this is out of a gasket set. This is actually the stock size exhaust manifold gasket, so this isn't like a header gasket. And notice how they're still that small. They probably opened up like, I don't know, like 35 thousandths or so. But what I did is I biased it toward the side of the exhaust exit, which is toward the outside cylinder wall. Or, well, if we were looking this way, going that direction. So I don't know, I just thought it would be a little different, and, oval is better than rectangular. So even though these are, they put rounded corners, so they're not exactly like a squared port like the intake is, but I just thought it would be neat to do something a little different, and they're still small enough to where they're going to have really good velocity. So that, and I started polishing the chambers on this one, and I still have some work on the one that I'm about to show you. Other than that, like today's video, I'm just showing a tool, and so I'm working on finalizing the outside wall of the intake, like exactly where I want to be, because I think initially I was a little small on it because I was being conservative because I didn't have this tool. So I'll just put this on the tripod. But yeah, I'm happy with those exhaust ports, and then I'll give them a final texture and just kind of blend anything left. Sand roll maybe. Okay, so where to start? So the problem with porting, you're a hobbyist or at-home porter, you don't have a machine shop, or if you're generally new, the problem is you can find a lot of people showing, porting E7s, but there's only like a handful or a couple that, I would consider actual professionals of the trade that have actually done workups on E7s in particular, because people consider them to be a waste of time. At the same time, if you look on YouTube, there's actually a Mustang, like a notchback, that's obviously, it's a bit lightened and it's geared, but it's running NA with ported E7s, and it's running 1090s. So how far can you take that statement that something is only good for one thing or it's garbage? I think for me it's been an awesome head to learn on, and it's also an awesome head because the amount of labor that you're going to take to do this, like anywhere from like 25 to 100 hours. Like 100 hours if you're really being careful, taking advice, like really following everything. And that's obviously going to slow you down because you're going to work slowly and check everything. And then as far as what I'm doing with cleaning up the chambers, the chamber mods don't take long, like the scavenge plateau and scalloping the spark plug bung. And some people will take out some material of the intake side on the outboard side here. I think like Charles Servetio does that, but then David Vizar doesn't like that. So I just kind of stuck to the DV thing where, you're doing a scavenge plateau and scalloping this a little bit, and then doing the spark plug bungs, and this helps with swirl. And then I'm polishing it up a bit. I was like, I should go with a thinner head gasket, like a 27 thousandths instead of a 47. At the same time, you know, the thicker head gasket's going to be a little more forgiving. Like, I put a straight edge on these heads. I'm pretty sure they're fine. The block was machined. I haven't really checked the deck height on it. So I'm just running with the stock gasket, but I'm pretty sure my bore clearances are a little on the tighter side. Like, they're still gonna fall within range for a 30 over. But that also will help with compression. But I'm really not too worried about it. And I think overall it's still going to make the power that I want it to make. And, with the tune on the computer, because it's speed density, but I have a custom chip from Motivation. So they took all the general specs and everything. And that gives it some electronic advance. So I'll probably still just out of safety, like, run like 89 or 90 octane. Actually, I noticed at the pump, when I drove a Super Coupe and had to run premium, it was 93. And I think even back then it was like $2.70 a gallon. And this is when minimum wage was like $6 something. I'm pretty sure it was like $2 something. I know I was paying well over $2. But I noticed they're only 90 octane now. At least at one pump I go to. So I'm wondering if they're... And that was like 4 something now. So... But in theory, depending on what the total timing is, like, it could probably still run on 87, but anyway. So I'm not too worried about that, because the other thing with a thinner gasket is then, like, if pushrod length comes into play. And I already bought my pushrods. I have old school... I had some NOS Wolverine Blue Racer hardened pushrods I found at the exact length. So the geometry should be spot on. Obviously, once I get these on the block, I'm going to check, the rockers and the valve stem tip and do all of that with like a marker and just make sure they're still there. And then you can go nuts and get like a pushrod length check, but it's just not in my budget. And that's the same thing with what I'm going to mention here. And so anyway, yeah, I cleaned my SD card, so I'm back to making these like 20-minute videos, but there's a lot of information to get out, Anyway, so you're doing this, maybe for the first time. You're not sure where to go. There's a couple, like 2 people making videos, and they don't like absolutes, so they're not going to say, oh, you go, where's my inside caliper? I love these things. They're like from, probably showed these before. These just happen to be the cheapest ones I had found on eBay, but they were patented June 2nd, 1885. Now, I don't know the actual manufacture date, that's just the patent date, but they very well are probably like 100 years old, so I love these. There's a little chip, not even paying attention if this is on camera, but the little ball there is only on one side, but that actually works really well in the bowls because sometimes you want that flat spot. But anyway, so let's say you don't have exacts, like, oh well, how far do I cut over and how far do I cut with a stock valve, right? Because we're only on a 176 valve instead of like a 185. I don't even think a 202 I don't think will fit in here, will it? Or maybe they do that. I don't know, maybe only a GT40, but yeah, I don't see that fitting there. I think you can only go to a 185 in this. But anyway, so you don't know what to do as far as that. You might know, unfortunately I can't really move the camera, but obviously on the center of cylinder side, you have this nasty dog leg on your short turn radius. And once you knock that out, that is around like 560 thousandths if you're blending that wall basically flat. So if you want to be safe, you can take your outside cylinder wall and just even it out because you don't know. But here's the thing. Maybe I can peek in here. If you look really carefully inside the water jacket, sorry, if you have a head at home, try this trick at home. But the thing with that is, if you really don't have an ultrasonic thickness meter, which I only got this because I scored it for like $50. I was like, you know what, it's worth it at the end of the day to kind of maximize this head's potential and exactly where I want to be because of how much labor is already into it. Not that you're totally wasting your time, because as it said, most of the airflow gain is from knocking that out and getting it out. Like, you're still going to end up opening this, but that and lowering the floor to like a GT40, I think it goes from like, if you measure the apex, I've showed this before, like I took mine from a, it's like a 1.240, and this opens a GT40, if you measure the window, is like a 1.34, so that's where that is now. And when I've seen flow bench testing where someone was like, okay, let's experiment with this, put it on the bench, that was where they started to get big gains and get closer to like 200 CFM. It didn't seem so much that the outside bowl was a big deal. But here's why this is important. Here's the other thing. If you start reading about general head porting or general head shape and so on, they'll tell you, oh, the roof of the bowl, below the throat, so at the bottom of the valve guide, is typically within 90% of the valve face. That's not true in this case, and we're talking about a 1.76 valve. If you opened up this bowl to that size, you're going to cut through just past 700 thousandths. So you'll read things about like modern cylinder heads and they do not apply to either just, this older design, what have you. So that's why it's important to always be like head specific. Like, you can watch videos, what to do, what not to do, and they're not all the same. Like, I've seen people try to match the E7s to a GT40 profile, and just because, like, even just the canting of the intake tunnel, as far as, like, how it's angled toward the valve, changes things. Like, I've seen people match kind of the S profile, and I'm probably going to cut some out of this outboard wall, too. That seems to help a little bit, but you can't just clone a GT40, and now I'll get into it, but the biggest reason being is that a GT40's bowl, from the outside diameter of the valve stem to the outboard wall, is about 760 thousandths. So it's pretty big with a 185 valve, considering the 176 valve. I did my stock measurements. I have them written down. I want to say they're about 460 or 470 thousandths. So huge difference that the GT40 has 300 thousandths more of room, which actually, where's my caliper? Because that's about what it's set at because of what I'm going to show you. So that's how much bigger this is. This is like 7 millimeters or 276 thousandths that this is set on right now, and I'll show you why. So that's how much larger a GT40 bowl is with a 185 valve. How much room, I don't know the casting thickness to the water jacket, like maybe the tunnels are thinner. I'd have to look up how big you can go. But I've also seen someone testing an E7. Obviously all castings are different, and then you get core shift, so not every intake is quite the same. But he broke through at about 720 thousandths. And a rule of thumb, especially for a street engine, is you want at least 125 thousandths. At minute, I wouldn't even go to, I would definitely not go to 100 thousandths. Where's my washer? So this is an 1/8 inch washer, to give you an idea, or 125 thousandths. So that's how thick you still want the area between your intake or exhaust, basically anything between a water jacket. That's minimum. Or else you're in danger of a crack or something, especially if you're gonna like actually, if you're building a performance engine, I would assume that you're gonna be going wide open throttle. Even if it's a street engine, I assume that you're gonna be doing like 0 to 60, 0 to 100, just stomping on it, basically wide open throttle, maybe going to the track. So that's important. So what I would do, because like I said, I'd try to ask, I'd be like, oh, like, how big should I make the bowls? And like, everyone, well, not everyone, there's really only a couple people, but they're like, I don't like absolutes. I'm like, oh, okay. So then I would try to determine it. Then I would try to do simple math, like, oh, well, my cam is changing the valve curtain by X amount. And if you don't know that term, valve curtain is just, obviously this is going to be huge because it's on flat, but the valve curtain is this area, the the diameter, or circumference rather, and then if you made this sheet, you know, took that value, like height and circumference, that's your valve curtain. So obviously, with a cam like this that's changing by 100 thousandths. So that means this is opening 100 thousandths more. I don't know how many more degrees of duration, because I don't really know the stock cam spec, but say like 80 or 100 more degrees. Something like that. Probably closer to 80, but... So I would keep that in mind when I would be cutting. I was like, oh, well, that changed 100,000, so this should be that size. And, you know, that's really just without fully being, having the education on that. And that's easy to get into with this, and that's why people assume things like, oh, I put my header gasket on the exhaust ports or any ports, and they do gasket matching, and they think that's what porting is, and it's not even close. In certain instances, that might change throttle response. That might change, that could be your pinch, or they end up changing or enlarging a cross-sectional area without knowing it, and, you know, you might get more RPM out of it, but that's definitely not that's not porting exactly. That's basically the final thing you're doing to make sure, like, oh, I have to, you know, port match, basically, not just gasket match, but like, especially, you know, with your intake, because the thickness of the gasket matters when you're lowering the intake onto the heads, how it's going to sit, and so on. So there's stuff like that, but other than that, like, it's best to just not use your instinct and find what you can find. And the only thing I could really find was how thin you're allowed to let this wall be. That's it. So all I knew was, oh, you have to be about 1/8 of an inch out. Now keep in mind, these are people that are putting 100 thousandths larger of a valve into the head, though. Right? So of course they're going to go well beyond, you know, they might go deep into like the 600 thousandths probably, because that's about where you'd be. So here's what I would do originally is you can get a pinky into this water jacket, and if this has some rough, you can see the gasket line. And I actually got desperate enough to where I took a little 1/8 inch carbide. Here's one right here, and I just cut that a little bit so my pinky would fit. And then you could take your other pinky, and that's, if you have a good feel with your hands, you know, if you do it, once you do a lot of porting, it's, you know, you're basically sculpting. I feel like you start to get that in your hands, and you can be a pretty good feel with measure. So that's what I was originally doing, and then I would take this, you know, 1/8 of an inch, and be like, oh, does that feel thinner? And that was a very crude and dangerous way of doing it, because unlike the aluminum intake, you can't just put JB Weld in here, like maybe if you really wanted to go nuts, but like drill a couple holes somehow and then make sure it's not going to go anywhere. But I don't want to do that on the head. So that's my original method. Then I take these snap gauges and I do like a chopstick thing, because that's also like, you can get a good feel for that, you know what I mean? And the funny thing is, I also was able to visually look down the water jacket and see just about how much this cuts in. And you can probably barely see it on camera, but there's a Sharpie right there. And here's what's funny about that is when I finally got the Sonic set up, and I'm more on that in a minute. And I've been talking forever, but like I said, there's a lot of information if you really care to do this for the poor people out there. The Sonic actually measured that out to be exact. So if you don't have the money for that, if you really go to one of these outside chambers, you can kind of feel it out. You can get a good visual and get a good idea, like, okay, that's about this thick. If you're really desperate. The reason why I started doing that again, because before I made more cuts in here, the problem with this ultrasonic, the probe that it comes with was like a little too big and it wasn't fitting flat. You know what I mean? And I still can't exactly get it on the bowl. Now, of course, they make smaller face probes, but it's not in my budget. I don't have like $70 just to be like, oh, I got a smaller probe. So the thing is, as long as you can get this in one spot, like especially right there, you know, or get it on the short turn, that's going to be enough where you can feel the rest of it out and get an idea like, okay, I don't know if I can do a live demo here or how well you're going to see this, but I'll show you real quick. So then I'll talk about the measure. I know I'm jumping all over the place, but so I take a liberal amount of hair gel. In an instance, I don't know where I put my Vaseline, but this works fine as a couplant. This is just, you know, go to the dollar store. Is it the best couplant? No. But it works. Or you can use Vaseline. And like I said, Vaseline is probably better for a vertical wall. And this is calibrated. It's accurate. I've tested it. It's metric, obviously, because it's Chinese. And let's see. See, I'm far away, so now it's telling me it's like 10 millimeters, which isn't accurate. So it should settle on about 7. I know 11's not accurate. So always go with the thinner side, like right about there. 7.7, 6.8. Making sure my probe can sit flush. But the funny thing is it will grab the couplant and read the thickness of the couplant. If I just take this off and I have a thick enough bead. See, now it's just... Yeah, now it froze. I don't know what it's doing. There it goes. Okay. So now we're back at 0. This is tricky to do with one hand. Either way, you can see that now I know about the deepest that outboard wall is cut, and I'm just past the valve guide if you can't tell. About as deep as that cut is about 7 millimeters. You can see the gel. Yeah, these bowls obviously aren't finished, but what that gives me, where I cut that was about, I had this set to about 585 thousandths, right? So that's, like I said, 115 thousandths larger than the stock E7 size, all right? The question is, you know, oh, and 7 millimeters, that's about 276 thousandths, or about that thickness. So that's really good as far as the head's integrity. Here's, again, the minimum. You can see the difference there. So it's a question now of like, well, where do I take it to? And will, you know, I can look down in the water jacket and see that that's accurate. And that was what was cool with the Sharpie. Like, that actually worked really well. and was really accurate. And I was a lot thicker in the wall than I thought I was. At one point I'm like, oh man, that's got to be like razor thin. Like it's probably 50 thousandths or less. And it wasn't the case at all. And obviously, like I said, this probe is a little big, but I'm confident that now that I carved some out of it, I got a big enough spot to where it's actually sitting flat. And again, it measured out. So, almost 300,000. So absolutely, I could take a lot more material off of that. But it's also a question of, keeping these heads alive. They're obviously 33 years old. Or no, excuse me, they're 36 years old. So it's a question of, wall thickness, integrity, and then it's a question of, stock valve, like how big do you not want to go, and so on. So that's kind of what I'm looking at. Is I don't think going beyond 600 thousandths would necessarily be worth it. And again, the GT40s are like 760, and their valve size is only 100 thousandths bigger. So that comes into question, like, well, where are the real changes? And like I said, supposedly it's mostly that dog leg, the short side radius, like lowering the floor. The roof is cut in on the sides a little bit. The push rod bulge and stuff like that. So I don't know how critical that really becomes, and really how much CFM it's worth, because that takes a lot of time when you're getting your final cuts in too, especially now with the ultrasonic, where I have to like gel up the port, like check it, like bite your nails, because I'm telling you, breaking through is not fun. I haven't done it on a bowl or a head, thankfully, knock on wood. But I've seen it happen, on my intake, and it wasn't deliberate because I was doing an epoxy port. It was like I did make a mistake somewhere, and it was the worst feeling, even though it was, I could correct it. But could you weld something like this? Yeah, obviously. But it's just a mess, and it's not worth it. So it's really, what it comes down to is knowing dimensions, where you shouldn't be, and your cam, and where you want your horsepower. Because the thing is I'd probably go toward the side of integrity and know that, okay, it only needs to make this much CFM for this horsepower. Like everything else is on point, it can support it. Is it really worth pushing to this or that? So that's kind of what I'm looking at, is, number one, making sure that this thing is really accurate. Because again, you can't totally fit it on the exact outside bowl wall. You kind of have to go just past the valve guide. So you're really kind of like having to trust that, and coming up with a figure like, do I go to 600? Do I go past that if I have that much wall thickness with the stock valve? So it's a lot to think about, because this is, I don't know how many hours are on these, like probably well over 50. Like I could be almost at 100. I probably am. So yeah, but if you find one of these for like $50, I would say it's worth it still for, junkyard stuff like E7s. It's definitely like the porter's tool. I wouldn't spend $300 on one if you're just doing a homebrew kind of project, but the question is, was this worth it for one set of heads for this project? Absolutely. Because I already had a pair of E7s that I ported with a freaking 1/8 inch carbide set, which took forever. And I made things that I would, I didn't know yet. And then the other thing is that it needed to be machined. So I said, hey, I'll just spend $100 for a set of E7s I know are good. And it's like, oh, well, why didn't you go with a GT40? And the answer there is I already had like $300 roller rockers set up for pedestal, and it's like, could I have returned them? Maybe, but you get into stuff like that with your budget to where you find a way to justify it. At the same time, I'm like, oh, it's cool, they're the actual truck heads and so on. Would I have ported out like GT40s instead to eke, especially since it's only a flat tappet? So I could have gained more also by going, roller and etc. So I would say it's worth it. Because the thing is with the E7s, with how much CFM you're opening, we're talking, opening about 40 or 50 CFM on the intake. The exhaust is opening like, at least like 30 CFM or more. And this is just the stock valves. So you're talking about potentially like what other things are in place and what the cam is. Like, it's 100 horsepower difference. So if you think $50 and like, your other tools and having to fix stuff that breaks once in a while is worth it, then absolutely. If you want to do it right and not ruin them. And again, make decisions. So, hey, like these heads will go another 300,000 miles. And they make just enough performance to where if you put this in a Fox body or something, it's a really hot street car. Like, you can get into the 11s with something like that without going crazy. So you don't really, like, that's the thing with today's horsepower, is do you really need that much more than 400 horsepower if you're actually using a car that's not a pig? Back when I had a Thunderbird, that was the heaviest car at like 3,800. Now that's a Mustang. So anyway, that's enough talking. It's been a while since I've talked that long about something, but if you're hanging in there, make those decisions for yourself, I guess. Better still, if someone was doing a step-by-step flow bench test, that's what I would like to see. If someone could like, oh, we're gonna take this another 50,000s or another 30,000s and then see what that does, where the lift numbers are, like how it affects mid-range, high range, etc. Because that's the other thing about it too that you have to consider. So, but again, I make these videos as kind of someone gathering knowledge from pros and then kind of showing my progress and how to do it the right way, because there's not enough videos where people are doing it right. They're like, hey, I'm porting my E7s or I'm porting my heads today, and they immediately right out of the gate make a lot of mistakes. Or if you read a dyno video, watch a dyno video, and the numbers are disappointing to you, and it says, oh, mildly ported E7s. Like, I never know what that really means. Like, does that mean they gasket matched it? Did they touch the bowls at all? Did they lower the floor? So there's a lot of questions I have, and then that gives it a bad name when, again, you go to the junkyard or find these on, well, you wouldn't want to pay off eBay for the shipping, but pick them up for $100, you can make a 10-second Mustang, so naturally aspirated. So that's not even considering boost. So are they a waste? I don't know. I don't think so. Are GT40s really more expensive? Well, that's a junkyard head too. You go on a Ford Explorer. So, but the point being is that they are that ubiquitous and no one thinks twice about them. So, but I just figured there should be like decent information out there if you are going to do it, so you're not wasting your time and not like, oh, I just need AFRs. And keep in mind, CFM isn't always everything either. So, and flow benches don't always tell the truth. Dynos don't tell the truth. It's always what the actual car is doing. So You know, even if you're just using your butt dyno, I guess. So, but I just happen to, you know, make sure I'm not wasting my time. And hopefully I'm not wasting your time by talking for 30 minutes. So I'm going to go ahead and cut this.